Assalamualaikum dear students. Today I am going to teach you Theorem 11.1 of class 10th, which is on page number 227 in your book. Statement of this theorem is, if two arcs of a circle or of congruent circles are congruent, then the corresponding chords are equal. Statement of this theorem tells you that you have to take the two arcs of any circle, but remind this thing that there are two cases of this theorem. How we have to take two arcs in one circle, and also let's suppose you are taking the two circles, but the two circles will be congruent. So there are two cases. In first case we will discuss the theorem for one circle, and in other case we will discuss the theorem for two congruent circles, as in figure it is given to you. So let's start this theorem. We are discussing the case A, in which we have to take the one circle. So I have taken a circle. Let's say it is a circle with center A, and we have to take the two arcs. So let's start that the two arcs are, the first arc is arc AEB, from this to this portion. Okay, so AEB, this is the first arc of the circle, and let's take the second arc, which is the arc CF and D. So I have taken the two arcs, and let's suppose that these two arcs are congruent. The arc AEB is congruent to the arc CFD. So we will write it in our given that a circle with center O center O AEB and CFD are congruent arcs of the circle, that is the arc AEB is congruent to the arc CFD. Okay, so let's take the two chords, corresponding chords in this. In the statement it is given that you have to take the corresponding chord. So the corresponding chord of the arc CFD is the chord CD, and also the corresponding chord is AB. So AB and CD are the two corresponding chords. AB and CD are the corresponding chords of these congruent arcs. Okay, now the next statement of the theorem is to prove. So in the next heading, to prove, what we have to prove, we have to prove that the corresponding chords which we have taken are equal. So we have to prove that these two chords AB and CD will be congruent. So this is the to prove of this theorem. In this theorem we have to do some construction. So construction of the theorem is, join O2 A, B, C and D. So you have to join the point O with A, B, C and D. So as we have joined the central point O with A, B, C and D. So let's name these angles which are making at the center, angle 1 and angle 2. So name the angles. Name the central angles as angle 1 and angle 2. Okay, the next step of the theorem is main proof, main body of the theorem. In main proof there are two portions. The first one is statement, and the second one is reasons. So in statement and reasons, we have to check the corresponding between the first triangle, which is the triangle AOB, and the second triangle, which is the triangle COD. So let's take the corresponding between these two triangles. In the first triangle, let's say triangle OAB corresponds to triangle OCD. Okay. We can say that OA, the side OA of the triangle OAB is congruent to the side OC. How can we say? Let's check in a figure. OA and OC are congruent because OA and OC both are the radii of the same circles. Radii of the same circle. Similarly, we can say that the side OB is congruent to the side OD. OB is congruent to OD. Same reason, radii of the same circles. Okay, the next one statement it will be angle 1 is congruent to angle 2. Why angle 1 is congruent to angle 2? Because both are the central angle of the arcs, which arcs are congruent to each other. So angle 1 is congruent to angle 2. Why? Because these are the central angles of congruent arcs. Central angles of congruent arcs. Okay, so we have discussed the three statements in which we have taken two sides and one angle. So let's search these two sides at OA, OB and angle 1. The side OA, the side OB and angle 1. Okay, we have searched these three terms of the triangle. So as it is clear from the figure that there is a postulate of side angle side. So we will write that these two triangles are congruent because side angle side of the first triangle is congruent to the side angle side of the other triangle. So we are starting to write it. Therefore, triangle OAB is congruent to triangle OCD because side angle side of the first triangle are congruent to the side angle side of the other triangle. As the two triangles are congruent, so we can say that each and every component of the first triangle will be congruent to each and every component in the correspondence of the other triangle. So as we have to prove that the side AB is congruent to the side CD, now we can write easily that it is proved that the side AB of the triangle OAB is congruent to the side CD of triangle OCD because these two are the corresponding sides of congruent triangles. So the theorem is proved